My name is Jimmy Lin. I work here at Google, and I'm happy to introduce Alan Cypher from IBM Research, the Almaden lab in San Jose. Alan's been working on end-user programming and intelligent agents for quite a while. Before at IBM, he worked at Apple, and some of the work that he worked on at Apple, he then co-founded a company called Stagecast. And so today, Alan is going to talk about end-user programming and how the field has evolved over the years.
Thank you. Thanks, Jimmy. So in this talk, I'm going to give an overview of end-user programming. But what I'm particularly interested in talking about is how the web has really changed end-user programming, because it's overcome some of the big, long-standing obstacles in the field. And so I want to show you some results of some new research that's being done that's real interesting in the area. So I'm going to start with a brief history of end-user programming, and then I want to answer the question of why would end users want to program? And I'm going to do that by giving 5 examples of practical tasks that ought to be amenable to end-user programming. And then I'm going to talk about the 2 main approaches that have been used to end-user programming and what the obstacles have been and how the web has really removed some of those important obstacles. And then I want to talk about a couple of the new research systems that I think are very interesting in the area. So to start with the origins of end-user programming, the first end users appeared on the Earth in 1980. And at the time, I was a graduate student, and I had a friend in comparative literature, and she did her thesis on punch cards. Now, anybody here who's under 30 probably doesn't appreciate the fact that if you used a typewriter and you decided to add a paragraph to your thesis, you might very well have to retype the rest of that chapter. And this alone was motivation enough for somebody who loved literature and had no interest at all in computers or programming. This was enough motivation for her to learn how to use a computer. So that was in 1980. And then in 1984, when the Mac came out, the notion of computer literacy came with it. And what that meant was, before that time, anybody who used a computer was a computer programmer. But starting with the Mac, there were these people who, when they use a computer, their use of it meant learning how to use the direct manipulation applications that came with the program. So when I talk about end users, what I mean is people whose use of a computer is constrained by the standard applications that are available with that computer. So that started off being things like Word and Excel, and then there were programs like Photoshop and iTunes and Skype came along, and as well you now have Mail, Instant Messenger, Google News, programs like that, and also websites like eBay or Kenneth Cole. And that is what end users do, is they use those standard applications. So given that these are end users, why is it that those people might want to program? And there's really 2 main reasons for that. The first is that inevitably you start having these repetitive activities that are very boring, and you wish the computer would just help you finish them. And also, people have idiosyncratic needs. This has been lately characterized in terms of the long tail, which means there's a few things that everybody does, and so it's good to have people write a program to do those things, but there's just billions and billions of things that we do that are particular to us that nobody is around to write a program for that. The notion of situational applications is similar in that you have a need right now for something that you need to use for a week or so, and then after that it'll be done. And then the final thing is that even if you have a standard application to do the kind of task you're doing, you might have these special needs that the designer hadn't thought of, and so you have to use that tool in some way that was not intended. Okay, so this comes to the notion of, why is it that we have this field of end user programming? And simply stated is that you have these end users who inevitably get these idiosyncratic repetitive tasks, and they would be willing to do a certain amount of additional effort to have the computer help them automate these tasks, but these people are not willing to learn how to program. And so the goal of end user programming is to find easy to use tools that will let these people get some of the power of programming without having to become programmers themselves. So now I want to give 5 examples of tasks that are the sort of things that ought to be amenable to end user programming. And these are situations that are practical situations that can come up in everyday computer use, where you as the end user wish that the computer would help you perform that task. And since these examples really always do seem to be idiosyncratic, I've picked 5 actual examples that have been cases where I wish that I could have end user programming. So here's the 5 tasks I'm going to talk about: saving with version numbers, calculating the cost of cable railing, paying my monthly credit card bill, getting hotel information, and then adding calorie information to recipes. And in fact, I didn't care about the calories, but I did care about the saturated fat. Okay, so the first example is saving with version numbers. Now, whenever I'm creating a document, I like to save it off with version numbers, because with experience, I find every so often I do something that's catastrophic enough that I wish I could just back up and use an earlier version. So let me give you an example of how I do that in Microsoft Word.
Word doesn't have a save with version numbers command, so I have to do it by hand. I save as, then go to the end of the file name and increment the number.
So that's an activity that's a repetitive activity that I do all the time. Now, the second example is that I had to replace the railing at our house, and I'd seen these cable railings and thought that might be a nice way to do it. But I thought they might be kind of pricey, and I really didn't know if it was something that I would think was too expensive or not. So I wanted to get a rough idea of how much they would cost. And part of the problem when I started looking into this is there's lots of different fittings and ways to make a cable railing, and they all have very different costs that they calculate in different ways. So it was really hard to tell which way would be appropriate. The third example is paying my monthly credit card bill. So every month I go to the web and look at my bill, and then after I see that the expenses are okay, I schedule an automated payment, and you get to pick the date when you want the payment to happen, and I always pick 3 business days before the due date. So what I would really like to do is press one button and have it show me my bill for the month. Then I look over the bill, see the charge is okay, and then I press one more button and I'm done. Why should I have to do any more work than that? It's a very repetitive activity and it's the same every time. The fourth task was a couple years ago when Kai was in Florence. I wanted to find a hotel that would be good. And there's quite a few sites out there that have lists of hotels. So I would go to these different sites, and what I would do is I actually made a Word document, and I would copy and paste information out about these different hotels, the name, the location, cost, maybe 1 or 2 of the reviews from people who'd been there. Now, this is a case where you certainly can't get one button that will automate the entire task for you, but there's so many parts of it that are repetitive, it would be nice if the computer would help me with the really repetitive parts of that task. And then the fifth example is adding calorie information to recipes. And these are situations that are commonly handled by mashups. And the idea is that the information is readily available. I have all these recipes on the web, and there's sites like Calorie King that have all of the calorie information for every item in those recipes. But I would like to have it easily combined so that whenever I look at a recipe, I can see the calories next to the items and see what the total calorie cost would be. So now the question is, given the tools that we have in end-user programming, how well can we do today in solving these end-user programming tasks? And what are the challenges that make this hard to solve? So let's look at the save with version numbers problem. In fact, this one is quite easily solvable, pretty much. I have a program called Quick Keys that I use a lot on my computers that lets you record the individual actions that you perform and make a macro out of them so that when you press a key, it performs those actions. So I recorded the sequence that I showed you, and you can see here are the steps. I picked the Save As menu item, and then I had to add a pause to make it actually work. And then it recorded the next command, which was I typed the right arrow key that moves to the end of the line. And then I pressed the delete key. And, well, Quick Keys actually doesn't know anything about numbers at all. Those are just characters there. So it doesn't know that there's a number to be incremented. So I let it delete the last character, and I, by hand, add 1 and type in the correct digit. And when I get to 19, I have to do an extra delete to change it to 20. So this is actually a good example of what we call mixed initiative programming, which is one of the solutions you use in end-user programming. And that is that a tool can be helpful to you even if it doesn't completely automate the activity. If it does most of the activity, the mixed initiative means that you do some of it and the computer does some of it. And so the two of you together can end up getting a complete solution that's better than not having the help at all. So let me show you, after I've made that Quick Keys macro, here's what happens when I press the Control S key that I assigned it to. And then I type the extra digit at the end. Yeah, one thing that I wanted to mention about this example is I talked earlier that this idiosyncratic use of an application is one reason for end-user programming. And this is a case where, the people who designed Word, they put a lot of features into it, and they could have had a save with version number command. They just don't happen to have it. So when they thought about the needs of their end users, they didn't consider this one idiosyncratic need that I have, and so I end up having to do that myself. And it's also a good example of what Don Norman has referred to as bridging the gulf of execution. And the gulf of execution is there's a task I want to perform. The computer doesn't perform that task. I have to find some way using the tools available in the computer to get it to do the task that I want it to. And the challenge that we see here that makes end-user programming hard, in this case, is we need to know some semantics. In this case, just simple semantics about numbers that our system doesn't have. So now let's get, excuse me, to the second problem, the calculating the cost of cable railing. This one has a well-known solution, which is to use a spreadsheet. And in fact, that's what I did in this case. That's the spreadsheet that I made to analyze 5 of the different ways that you could go about putting together a cable railing and find out how much it costs. And in order to do that, I put in some formulas like this. So I used floors and conditional statements. I know how to use the dollar signs to get some of these equations to work right. And then I did lots of adding and multiplying. But when you look at that solution, you have to say, my God, what a geek. Can you imagine? Look at the people in this audience might be the entire collection of people who'd be willing to go to that effort to solve this problem. I mean, anybody else could very easily have said, well, you want to know roughly if you can afford it. So I have 75 feet of railing. There's 10 cables on each one. And then I've got 6 sections, and each section is going to take 20 connectors. So, in about 15 minutes, you could get a ballpark figure for it. So part of what I want to mention with this example is there's different classes of end users, and some are willing to be, do a lot more geekier things than other ones. And in particular, with spreadsheets, spreadsheet programming, it's one of sort of the mainstays in end user programming. But I just want to caution people that it's a very special case. It's different from every other kind of end-user programming. So first of all, a program like Excel is actually a development environment for creating programs. You know, you're using the tool actually to create programs. And the other special thing that's important is people who are using spreadsheets are doing mathematical things. They're doing mathematical calculations. So a solution that involves typing in formulas may very well be appropriate for this end-user audience. But what constantly astonishes and annoys me is that people in end-user programming then think that this is applicable for other end-user audiences. And I think there's really no other end-user audience where it's appropriate to give them formulas like that and think that that counts as a solution for non-programmers. Okay, now the example of paying my monthly credit card bill. This one, I'm currently working on a system called CoScripter at Almaden, and it is a pretty good system for solving this problem. So CoScripter lets you record actions like a macro recorder, but it's programming by demonstration in that it's able to abstract the solutions and do more than just do a literal playback of what you're doing. So when I recorded one time my process of paying my monthly credit card bill, I was able to make a script out of that that automates the entire process except for one of the steps. So I can pretty much press the button, look over the bill, press the button again, and be done. There's just one step where I couldn't quite do that. And what I wanted to point out here is how this differs from a macro recorder. In this particular system for Wachovia, when you pick which account you want to use, in the pull-down menu, they add your current balance to the name of the menu item. So you have to do things like, say, select the item that starts with, rather than selecting exactly that item. And then also we have variables so you can do things like you can put in an abstraction of you want to pick the current month out of the menu. And those are things that typically you can't do with a macro program. And let me show you the one step that the program isn't able to do. As I told you, I like to select the due date as I want to select the payment date as 3 business days before the due date. And in this program, it brings up a little calendar widget like this, and there's a blue square on the due date. So I would go in by hand now and click on the 26th in this case. And while I'm here talking about CoScripter, I just want to give a bunch more example of the sort of tasks that end users might want to do. I have a script for reordering ink for my printer. I have one for sending email to my representatives in Congress, which is very useful, and I've been a lot more vocal lately. And then I have one that every month I like to download my Amex account into Quicken. And then to give you some ideas of the kinds of scripts that it's nice to share with other people, opting out of a credit card offer, there's a site and a way to do that. Now, even though I created that script, I'm only going to run it once, but it's nice to make it available to other people. The same way there's a way to get this IBM flu shot coupon, which is incredibly torturous, but since I recorded doing it once, then it's easy for other people to do it once. I love using my script for the Southwest Airlines boarding pass because they assign your seat position based on when you sign up for it. So I run this like 1 minute after the time is available. And then I have a script for forwarding all my phone calls to home because we have these voice over IP systems. So these are things that are useful to a lot of people. Then to get to the fourth example about gathering the hotel information, this is another case where there's new work in end-user programming research that really solves this problem very well. Mira Dontcheva has this program called Web Summaries, and it's neat because almost like spreadsheets, this is like a whole different genre of user activity that came about with the web. So the fact that you need to do information gathering is a prevalent activity on the web, and she came up with a very neat solution that addresses this. And I want to give you a short demo showing how that system works. Okay, I think I have to, let me run this by, I'm going to run a little video here. And it doesn't have a soundtrack, so I'm going to be the soundtrack. It's not on your screen. Let me see if I can. I won't spend too much time trying to do this. Okay. So you see there's a little toolbar up here that's the Web Summaries toolbar. And she first clicks on this button and now is going through on this sample page, this one example of a hotel, and marking all the different items. Like this is the name of the hotel, this is the price, this is the address. And after she's done that, the system puts together, using a little template that she has, of all that information that she's collected for this one hotel site. But now she's taught it where the hotel name and the address are on this hotels.com site. So now when she goes to a page and sees a different hotel that she's interested in, she can just click the button and have it use that template that it's already formed so it knows to get the information, and it does this entire information from that site all at once. And then even better, now that she knows how to handle hotels on this site, she can go to this list and just click on the links of sites, hotels she's interested in. And without even navigating there herself, the system will go off to all of those pages and grab the information and put them together. So it really is a very nice solution that automates the part of the task that can be automated. And the fifth example that I had was adding the calorie information, so doing a mashup. And there are lots of tools out there now to do mashups, and they have different levels of being usable by end users. But to me, what's most interesting about this problem is the challenge that I've got these different food items and I want to find them on another website. And there's this wonderful program by Alex Faborg. He did these programs called Creo and Mira, and he does the rather amazing, to me, new part of this task that could never have been done before, which is when he goes to a web page, he'll highlight in red all the parts of that web page that are food items. And the way he's able to do that is by using ConceptNet. And ConceptNet is this system that is a semantic network that people can add to at any time. And it knows things like that Coca-Cola is a beverage, and it knows that beverages are food items. And so this opens up a whole new area of work in end user programming that no one was able to do before. And although it's very early work in this area, it really is sort of changing the whole environment of doing end user programming. Okay, so with those 5 examples in place, I now want to talk about the 2 main approaches that are used to end user programming. And the idea here is programming is fundamentally a hard thing to do. And so there's 2 ways that typically people in research have been going about trying to solve it. One of them is using scripting languages, and the other is using programming by demonstration. So here's what is it about programming that really makes it hard? And why is it that conventional programming languages that for most end users, they're daunting and they're unappealing? And basically the answer is that programming is indirect and it's abstract. So if I want to do something like tell the computer to click the button, all you have to do in JavaScript is say the event.initMouseEvent, and then supply the correct 15 parameters to that. Now that's very indirect and remote from clicking on a button. And it's obscure, it's unforgiving, the details are abstract, and it's really only indirectly related to the simple act that I'm trying to do. So in end-user programming, how do you go about dealing with that problem? And there's two main approaches. The first approach of scripting languages says, look, the power of programming comes from this ability to do abstraction. And the way you do abstraction is by using language. So we're going to have a language, and we're going to have to just accept the fact that it's going to be indirect. But given that, let's see what we can do, at least to make the languages a little simpler and easier for people to use. So generally, this camp of researchers are people who aren't really overly focused on end users. They just care, they just think programming is hard, and they're trying to find other ways to make programming easier. So this includes people who work on like kids programming, and also there's just lots of people who are trying to take standard programming languages and try to make it a bit easier to use them. Here are some examples in the web domain of scripting languages. GreaseMonkey is a tool that doesn't make the programming part any easier, but what it does is it gives you as an end user, or at least as a user, access to the content of web pages on your computer so that you can use JavaScript to modify the content of pages that you're looking at. Then a considerable improvement over that is a system called Chickenfoot out of MIT. And what they do that's very neat is they make it a bit easier, so they have commands like click and replace, which makes it a bit more natural. But the real innovation here is they let you refer to objects on the screen by using what a person would call that object. So for instance, they'll have a button and they'll call it the submit button because that's what the text on the button is. Or maybe it's in a table and the label is to the left of it, but they know that a person would use that label to refer to the button. And that makes it much more usable for end users. You don't have to know the X path to that button, for example. And then the system I'm working on, CoScripter, takes the idea behind Chickenfoot farther and tries to make a scripting language that is just easily human readable. And so it both records that and makes this language that people can both read and the computers can execute it. So then the other big camp of solutions for end user programming is programming by demonstration. And the idea here is that if you as an end user know how to perform a task by hand yourself, then that's pretty close to writing a program for it. So what you do is you turn on this recorder and you demonstrate to the computer how to do the task, and then you let the computer make the abstractions for you and infer what your intent was when you perform those specific actions. So this is much more an artificial intelligence approach. You know, it's not going to work all the time, but the idea is if the computer can guess a solution and present it to you, it's so much easier for you to just verify, say, yeah, that's it. And it's just a much easier way for people to create end user programs because they are dealing directly in the interface and they're not going through this abstract indirect language. The big limitation is this isn't as powerful. It can't do as many things as a scripting language, but it really changes the notion of ease of use very dramatically. So what are some of the challenges that have kept end user programming from being really widespread and successful? One of them is that there's a limited audience. So it's limited for several different reasons. The other is this notion of inferring the user's intent. That's just clearly going to be a hard problem. And the third is that you don't have semantic information available that you really need to to be successful doing this task. And here's where I get to the part about what's changed with the web. Now, the reason the audience was limited for end-user programming systems is it used to be that anybody who did research in this area had to use toy systems in limited domains. And that's really changed because of the web browser, in particular because of the Firefox browser. It's completely changed that equation. A second notion is that you used to have end users who were sort of scared and timid, and it was hard to get them to try any technique like this, and end users now are different from the end users in 1980 or even in 1990. And it also used to be hard to share your solutions, but now that end users are so used to creating user-generated content and putting it on the web, it's overcome this problem. So now there's a lot more motivation for why people would want to do end-user programming, because other people can use it. So let me go over these steps in a little more detail. Back in 1988, Ian Witten wanted to do some end-user programming, programming by demonstration, and he wanted to do it in a domain of text editing. Well, at the time, all text editors were proprietary closed systems, so in order to test out his ideas, he had to write his own text editor that had recording and scriptability in it. So not only does that give you the problem that you're spending all your time writing a text editor, but it also means that in order to test out his system, he could bring in 2 friends who would sit in the lab and try it for a week, and that's how he would get his results. And after the end of that, then it was done, and nobody used that program again. Another problem is that even if he had gotten a great solution in that, it wouldn't work for text editing, say, in a chat program or an email program. Those are all separate applications that he hadn't automated. So in 1993, researchers did understand that. A group of people came up with a system for application-independent environments for doing programming by demonstration. But you had to use their tool, which means you actually had to write in Smalltalk. And again, it wasn't a successful solution, but it just shows how, in 93, researchers were aware of these problems, but they didn't have any way around them. And that all changed with the Firefox web browser. So now you've got an application that is actually being used by real people in their daily lives, millions of people, and there's many applications that are on this. It's sort of like an OS now, that there's many different applications that run on this one platform. And the most important thing is that there's an extension facility so that people who are doing research in this area and other areas can write their extension and make it work in the Firefox program and have it be usable by millions of people. The second thing that's changed is end users, and that's really not a function of the web. It's really just fortunate timing. So what's happened is that the people who use computers now are very different people. In particular, I have a nephew who's 10, and he does not remember a time when he didn't know how to use a computer. He would sit down at a computer and use the mouse and pick items out of menus before he could read and before he knew what those menu items meant. So if he sees a new application and there's some menu item that he doesn't know what it does, or a button he doesn't know what it does, he clicks it and sees what happens. And in 10, 15 years ago, and if you look at people over 40 today, they're afraid to click some button because something bad might happen and they don't know what it is. And those users, if you work in an area of research like this, you might just not worry about them anymore, because they're not going to be around that much longer. And there's this whole new generation that you can appeal to that is going to be ready and willing to use your tools. And then the other fact that people using computers now are very comfortable using YouTube and Wikipedia and other sites where they put up user-generated content. And there's a site called userscripts.org for Grease Monkey. So if we do get tools that are easy enough to use for making scripts, it's now trivial and easy for you to share your script with other like-minded people. And that's a real additional incentive to why you might go to the extra effort to make one of these scripts. And Bonnie Nardi looked at spreadsheet users many years ago and showed this effect, how you get a whole range of people with different skills forming a community. And there's some people who are the geeks, can do the really tricky part, and then there's others who mainly just use the tools. But by having a whole community, it makes use of the tool a lot more successful. So the bottom line on this is that the path really is clear now for large-scale adoption of end-user programming. It's just a matter of making the tools easy enough to use. So I've talked about this challenge of the limited audience. Let's look at the other two challenges, inferring intent and the semantics. So what's changed with that now that we have the web? Well, the answer to the first one of inferring users' intent is that hasn't changed at all. That's the fundamental challenge in programming by demonstration. And the two tools that researchers in the area use to solve that are getting contextual information and using multiple examples. And those are sort of the two tricks that can be used to try to solve this problem. And nothing's changed there. But the other place where the web has really revolutionized things is this problem of having missing semantic and domain-specific knowledge. Now, all of this semantic information is readily available, and that really is changing things. So again, if we go back to Ian Witten in 1988, when he did his text editor, this is a problem that he wanted to solve. You have a list of addresses, and say now you want to add them to your online address book. Well, you don't know the semantics. You don't have any access to the semantics, knowing what people's names are, what addresses are, and zip codes. So what you have to resort to is finding some way to use syntax to do the best job you can to come up with understanding these semantic concepts. And I particularly like his example because these are addresses in Canada. And this gives you an idea of what the challenge is to a computer, because when I look at these zip codes, I go, well, is that a zip code? Let's look at that one that's like L_J4. Does that count as part of a zip code? Who knows? So the interesting thing here is that this isn't just a challenge for end-user programmers. This is a challenge for every programmer. If you were a professional programmer and you were going to write a professional program to import address data, you would have to figure out some way to identify zip codes, and you would probably end up doing the same thing of trying to find some syntactic rules that would do the best you could at finding what was the zip code. But what's happened now with the web is all of a sudden there are lots of tools out there that solve this specific problem. There's all sorts of data detectors being built that are smart programs at detecting addresses, at identifying things as people's names, at knowing what a phone number looks like. And data mining has all sorts of techniques for looking at unstructured data on a web page and figuring out where in that is a person's name and where in that is an address. And microformats are another technique that's being used to make this semantic information available to us. And also there's websites that do semantic work for you, like calculations on dates that you can add and subtract from dates. And you can also format dates in many different formats you want. So all these tasks that used to be really problematic, and people doing research in end-user programming 15 years ago, they spent so much of their time trying to make it easy for a person to write these programs that would do tasks like identify zip codes. And that problem has really just gone away now. So let's get back to the example I gave where in my program, CoScripter, we can't handle this one step of picking 3 business days before the due date. Suppose we have recording of this widget. Well, if you don't really know much of what's going on, when you record the user clicking on that date, it might just get recorded at clicking at this mouse location in that widget. And at that point, that's rather useless information. You can't figure out much from that. There's no semantics there. The next best thing is if you were able to record that as set the payment date to August 26, 2009. So it knows that that particular square corresponds to August 26th. And then what we would like, the best thing would be from a recording, to figure out that that click, we inferred the user's intent as set the payment date to 3 days before the payment due date. And that's really not an impossible thing to do. To go quickly over these tricks I said of programming by demonstration, the way you do that is if you have this high-level event of click on August 26, you record with it a bunch of contextual information. And part of the context of using that calendar was that there was a blue square, which we know is semantically the due date, and it was on August 31st. And now if I have domain-specific knowledge that I can take August 26 and I can add 5 days to it and know what date that is, Or if I have a business calculator and I can add 3 business days and end up with August 31, now you're in a position that if you get a couple examples of the user doing this task, you can make a reasonable inference that they're picking 3 business days before the due date. Now I want to move to another challenge that's sort of a rising challenge in end-user programming, and that is what's happened now that we're moving away from HTML. Now, when HTML came out, that's really what made the web successful, because it was this simple declarative format. But in terms of user interface design, this was the great leap backwards. You know, people have been making these really nice desktop applications, and all of a sudden you get a web page, and you can't drag and drop. You can't select out of a palette. You know, all these things are just gone. And sure, it was easy to use, but it was really a miserable user experience. You change something on the page, so then you redraw the entire page. You know, there's no dirty regions or anything like that. So it really is a very primitive experience. And you know, thank God now we're getting back to making interfaces that are richer and smoother. And a lot of that has to do with using tools like Ajax. But in the process, this is becoming a challenge for end-user programming. So it was very easy in end-user programming to make a recording that recorded whatever tag was clicked on. And if you know that it was an A tag, you know that it's a link, and you know all sorts of semantics about it. And what's happening now is, in particular because of things like rich toolkits that give you these richer experiences, a lot of that information that used to be declarative is now becoming procedural. So it's being hidden inside some JavaScript program. And as a person doing recording and trying to do end-user programming and further user's intent, if it's in a JavaScript program and it's not declaratively available, it means that you would have to read and understand that program to know what's going on semantically. So this slow crawling back to getting rich applications on a web page is presenting a challenge for doing end-user programming. And to give you one example of that, there's this Dojo toolkit, which is one that's used a good bit inside IBM. And I decided to add the information I needed so that we could do good recording in CoScripter for all the different Dojo widgets. Now, one of those widgets is called the Form MultiSelect widget, and that's where you want to get a pull-down menu, and you want to be able to pick more than one thing out of that list, okay? Well, when I went to instrument that, this, if you look at the text on the left, that's what that widget actually looks like. So this is sort of true of all of Dojo. Instead of having an A link or some sort of tag that has semantic meaning to you, everything in Dojo is a div. So you look at it and you have no idea what it does. It could be a calendar, it could be a pull-down menu, it could be a dynamic tree, and it's actually just a div. You have no idea what's going on there. So I was going to get this example to present in this talk, and when I went back to get it, I actually found this text on the right, which is this select tag. So it turns out in the couple of months since I looked at that, the people developing Dojo, for reasons I'm not completely sure about, realized that it would be better to be a semantically meaningful activity like select, and they put in this Dojo type field that tells me exactly what widget it is. So now all you need is to have one person go in there and mark up this widget and say the digit form multi-select is this kind of widget, and here's all the semantics in it. And all of a sudden, that problem is solved again. So there is hope available. And in particular, it's really interesting that a lot of this hope comes from the accessibility field. So people doing accessibility, in particular, people who are concerned about making websites available to people who are blind, face exactly the same issue. There's a div tag out there, and for a blind person, they need to know that that's actually a calendar and has the semantics of a calendar. They need to know that that thing that was clicked on is actually a date. So because of this need, there's a good bit of work in accessibility about making tools available so that you can mark up a web page and add semantically meaningful information to it. In particular, there's this ARIA spec, which is accessibility for rich internet applications. And it's specifically designed so that you can add semantic information about custom widgets. And another interesting thing is there's this project at IBM now called Social Accessibility, and it's a toolkit so that people who need accessibility information can request it from this global community. And when somebody adds this information, like marking up one of these widgets, it becomes universally available. So there really is a mechanism in place to start making this information available and useful. So this challenge that we have for end user programming, it turns out that accessibility may be the motivation and a reason why, in fact, we do get a good solution to this. So just to sum up, what are the changes that the web has brought that has gotten rid of some of these obstacles to end user programming? The first is the web browser. The second is that end users are no longer afraid to use computers. We have these communities available to create and share content. And this very important fact that now semantic information is readily available. And that one was really the one that was the biggest obstacle in end user programming. That just seemed insurmountable. And that change is really having a dramatic effect. And so it's very neat to say that in the last couple of years, because of this, there's a dramatically increased interest in end user programming. There's much more research going on in the area. And I've already showed you these two programmers, the web summaries and the Creo systems. And I want to talk about just a couple other of these really interesting new systems that point the way for where end user programming is going to go. So one of them is called tutorials by demonstration, and this is out of Manish Agrawala's group at Berkeley. And it's very interesting because as I've been telling you how important semantic information is, this is neat that it goes in the exact opposite extreme direction, which is it looks at the pixels on a screen and does processing with the actual bits on a screen. And this work was done back in like around 1992 by Richard Potter. He built the first end user programming system that worked on the pixels on the screen. And it's amazing the number of things that you can actually do effectively this way. And one great thing about it is it's cross-platform and cross-application. It just takes those bits and does something with them. So it's a very interesting, different kind of solution. But what's happened now, you know, this area of research has been dormant for 15 years. What's happened now is that people like Manish's group, and also there's a product called Sikuli out of MIT in Rob Miller's group, that are using vision algorithms. And so that gets rid of some of the brittleness of working with pixels. They can actually identify something that's about the same even though the screen resolution has changed, for example. And so they're starting to use vision algorithms to make this approach really quite effective. And it's very interesting to see the things that they can do now. So let me run this short demo of the tutorials by demonstration system.
We present an approach for automatically generating step-by-step visual tutorials for photo manipulations. Our work is inspired by professional tutorials for digital photo editing, such as this one for changing the eye color, and this one for creating night from day scenes. We start by recording all changes in both interface state and application state as the user demonstrates a manipulation technique. Here, the user wants to change the eye color in this portrait. He starts by zooming in on the eyes. Since he's not sure which tool to use next, he has to read several tooltips. He eventually picks the ellipse selection tool and selects the eyes. But his selection is too big, and he has to adjust it several times until it just covers the iris and pupil. To change the color, he clicks on the color menu and looks through the available options. He selects color balance and starts adjusting the green slider. He clicks OK, but then decides the green is not quite right. He opens the color balance dialog again and adjusts the other sliders until he is satisfied. Our recording includes all changes in both interface state and application state, as well as screenshots of the application every time the mouse is clicked. We process this data to automatically generate tutorials describing the recorded manipulation technique. First, we associate changes in interface state with the corresponding changes in application state and eliminate unnecessary steps. Then, we group together multiple parameter updates for each operation. Finally, we group consecutive operations. The remaining sequence of steps is used to generate tutorials. Here's the tutorial we generated from the eye recoloring recording you just saw. We use computer vision algorithms to determine that the user was manipulating the eyes, which allows us to generate descriptive text that says to select the pupils and irises here in step 2. Using our system, we have generated tutorials for several portrait and landscape retouching techniques, including the ones shown here.
Okay. I'm running out of time, but just one last system that I want to quickly mention is Margaret Burnett's work on surprise, explain, reward. And what's interesting about this is it's opening up a whole new area, a different way of looking at end-user programming. And they call it end-user software development. And the idea is that you have all these end users out there producing systems, and research shows that end users are, probably like most people, are inordinately impressed with their ability to create programs. And in particular with spreadsheets, they really think their spreadsheets work right when in fact they don't. So she's interested in applying some techniques from real software engineering to help end users notice that there's problems in their software and improve them. Now, the idea is you don't have a captive audience when you're doing end user programming. So in order to encourage people and get them interested in looking for bugs, she uses this technique from psychology called surprise, explain, reward. Basically, the idea is if you can show somebody something unexpected, that'll surprise them, get their attention, and that causes them to be interested. So her systems that work in spreadsheets, what they'll do is they'll analyze the formulas behind a spreadsheet, and they'll notice, what are legal possible solutions to some of the formulas in there. And then they'll try to present examples that give values that they expect are probably incorrect. So for instance, if they notice that there's a cell that's labeled day of the week, and they can have it turn up a value of -4, that's probably something that will get the end user's attention. And having captured them with this surprise, you explain and then show them exactly why this wrong name came in there, and then the reward is that they can then fix that. Okay. So to finish up here, what's next in end-user programming? Well, I'm hopeful that what's next is that end-user programming will actually become prevalent and successful on the web. And I just want to mention that the next area where end-user programming really is going to a natural fit is with mobile computing. So when you're using mobile computing, first of all, you have very limited screen size. So every pixel is precious on the screen, and it's valuable to be able to create a custom solution that just shows the information that you care about. Second, there's these impoverished input methods. So if you can automate a task and by doing a single click, do what would otherwise take 10 actions to do, it's very worthwhile to you. And finally, you have limited attention because you're busy driving while you're texting. And so if you can have automated solutions, that will also help you get done what you want to do. So my summary is that the web has brought this great new opportunity for end-user programming. We have a different class of users now, and we have all this rich semantic information available. There's still this challenge that as applications on the web become richer, it's going to pose a challenge for us. But accessibility may really be the solution that will resolve that problem. And finally, mobile computing looks like the next good area for work. And just to conclude, I started collecting the material for this talk when I was writing an introduction to this book on end-user programming on the web. And the book is now going to come out in time for Chi. And it's already it's listed on Amazon and on Morgan Kaufman, so if you want to check it out, you can get information about it there. Okay, thank you. Any questions? Yeah.
The issue about what happens when the system generalizes wrong. That's one of the things that I notice in my main personal experience of programming by demonstration, which is Emacs macros, which I'm not recommending as an exemplar of end-user programming, but nevertheless, there's an interesting thing which I notice about it, which is because it has several different ways to navigate, when I'm in macro recording mode, I know what generalization I want it to form effectively. So what I do is I navigate to the destination in such a way that I know that those navigation actions abstract over the set of cases that I want it to apply to. A good example of the same principle hypothetically is in your calendar example, if the way I select the date 3 business days before the due date might be that if the selection starts off on the due date and then I somehow go back 3 days. So I'm wondering, first of all, how to help guide the system to make the generalizations the user wants, how to present the user with interactions which enable the user to have an intuition about what those generalizations are, and also when the system does generalize wrong, to help the user understand what to do to correct.
Yeah. Those are all really important points about issues with end-user programming. A few comments on it. One thing is, when I did this eager system in HyperCard many years ago, the issue of navigation was an important one. So if you went from one card to another in HyperCard, you could do it by clicking next buttons. You could do it by going to a picture of all your small cards and clicking on the one you wanted. And the way that system dealt with navigation is you could actually navigate any way you wanted to, and it would still find the correct pattern, because it had this semantic concept of navigating in card numbers. So it knew about the first card in the stack, the last, the number of cards, the next card, and so on. And what Eager did is it took more than one demonstration. So as long as it had a few examples, that's really the magic that solves the problem of ambiguous interpretations. There's just a combinatorial explosion in the number of possible inferences you could make about what one user action does. But after you've seen the user do that action 3 times, in most cases, it comes down that there's really only 1 or 2 that are consistent with those multiple examples. So that's the general approach that's used. And that actually worked very well in HyperCard, that somebody would navigate in completely different ways and change their scheme, and it would still detect the pattern anyway. But it is a huge problem about giving wrong inferences. And in that same program, I had this great example of what the problem was. So we were doing a pilot study, and it was there were cards where it was this Da Vinci, the character with the arms go like this, and you're supposed to animate the arms of coming back down. Okay, so it's copying all the cards in the reverse order. Well, this guy who was trying to solve it didn't know how to use HyperCard. He didn't even know about copy and paste, really. So he wasn't able to do it. But somehow, in his floundering, there was some pattern that Eager picked up on. So this little character pops up and says, finish the task for you. He goes, oh, sure, and he clicks the button. And then it's just flying all around, and things are happening. And then at the end, his comment was, well, I just wish it would go slower so it could teach me how to do the task. So the point is that, here's an end user that doesn't know what's the state of the art in artificial intelligence, and doesn't know whether the system can figure out from your actions that here's really what you wanted to do and here's how to do it. So it's a very serious issue about coming up with the wrong inference, and what do you just do, how does that could cause huge problems for your end users. So it is a very real issue. But the answer in general is if you have high enough level semantics and you get multiple examples, you can do a good job. And then the other answer is you need to have some way that once you've come up with an inference, you have to be able to present it to a user in the way that they can understand the inference you made. And the way Eager would do that is it would show you a specific example of the abstraction in the current context. So it would show you a concrete example, and you could validate whether that was right or not. And that helped a lot. Yeah.
Can I ask a question?
Yes.
So there's the inference problem on the part of the machine. There's also the inference problem on the part of the human. So I'm curious about what you're thinking about the human's mental model of the agent that's making inferences about the stuff you're doing such that I can predict what it will do. So for example, you showed the drawing, the circles on the eyes, and I was blown away. I didn't believe we'd be able to infer irises in general, right? So the bigger problem becomes, how do I know what this machine can do? I mean, you know, and how do you portray what it can do? Can it do arbitrary multi-language translation? How do I learn the boundaries?
Exactly. And that's a huge problem in this field and with almost any tool, because you as an end user don't know the extent of its capabilities. Like when I built this system for kids programming, this Stagecast, there were a bunch of other systems out there. Like there were logo systems that you could use. There was agent sheets. And if you gave me they were all ways that you could make simulations and then have interesting things happen because you build a discrete event simulator. If you gave me a problem and you said, I'd like to be able to do this, I could tell you, oh, don't use Creator. You should use agent sheets for that. And then for some other problem, I would say, oh, don't use agent sheets for that. You want to use Creator for that one. So, and how do you tell people the capabilities of your system with? And I sweated over that issue for a long time, and I don't know any good answer to that at all. I think that's a huge issue. And it's also going to be one of the reasons that makes end-user programming hard to pick up. Because if you're going to try a tool, the first time you decide, I hear this tool will work and help me automate this, and you try it, and it doesn't work, well, you don't know why, but you're not going to use it again. You have no idea if you picked a task that was amenable to that tool. And to me, I think the best answer around that is this social answer. That once you get websites where people who have learned the tool and have put in enough of the effort show you 150 examples of things it can do, then you say, oh, the task that I have to do is a lot like that. And since it can do that, I'll bet it can do mine. And I think that's the best answer, is by having lots of examples. And so, having the web makes that a much more feasible solution than it used to be. Anything else? Okay. Thank you.